Alright, now that you know the very basics of what an Elasticsearch cluster looks like, let's take a moment to inspect the one that we have running. To do that, let's open up the console tool in Kibana. You can find it by clicking the DevTools menu item. This is the first time that we'll be sending a request to Elasticsearch, at least through Kibana. As you might remember, an Elasticsearch cluster exposes a REST API, which is what we'll be communicating with. Essentially, this means that the HTTP verbs differ depending on what we need to do. By HTTP verbs, I'm referring to get, post, put, and delete. Although we'll be typing in our query within Kibana's console tool, Kibana still uses the REST API under the hood. On the Elasticsearch end of things, an HTTP request is received. This request is treated the same regardless of where it was sent from. As long as the request is valid, we can access the REST API from any HTTP client of our choice, such as curl, Postman, etc. You'll see an example of this in the next lecture, but for now let's use the console tool. The format in which we need to enter queries within console is to start by specifying the HTTP verb. Let's begin by retrieving information about the cluster's health. Since we'll be retrieving data, we'll use the get verb. Next, we need to specify the request path, being the part following the address. When using the console tool, we should not specify the address, since this is specified within Kibana's configuration and will be prepended to the resulting HTTP request automatically. To retrieve a cluster's health, we use the following request path. As the first thing, I want to mention that deleting / is not required when using the console tool. If you leave it out, Kibana will add it before sending the HTTP request. So whether or not you include it is up to how explicit you want to be when writing your requests. I like to include it, but that doesn't mean that you have to. Alright, so let's briefly talk about the request path that we specified. The _cluster part specifies the API that we want to access, whereas the health part specifies the command. APIs begin with an underscore by convention. In place of health, there are a number of other commands that can be used to retrieve detailed information about the cluster and its nodes. These commands yield results that are too complex to get into right now, so let's stick to the health command and run the query. On the right hand side of the screen, we can see the results of the query, being a JSON object containing information about the cluster. The cluster's name is set to Elasticsearch, which is the default value. You can configure this to a more meaningful name, which you learned how to do a bit earlier. We can also see that the status of the cluster is set to green. You probably won't be surprised that this means that everything is okay and that the cluster is healthy. We will revisit the cluster status in a couple of lectures, where you will see a situation in which the status is no longer green. Let's continue exploring the cluster, this time listing the nodes that are part of it. For that, there is an _cat API, which outputs data into a human-readable format. Within the _cat API, there is a command named nodes, which does what we're looking for. So let's type that request out. Before running the query, I'll just add a query parameter named v. This query parameter instructs Elasticsearch to include a descriptive header within the output, so we can identify each piece of information. Let's run the query. The results show some basic information about the single node that we have running, including its IP address, name, as well as some performance measures. In Elasticsearch, a node has a number of roles associated with it, specifying which actions it can perform within the cluster. We can also see that the node is a so-called master node. I'll get back to both of these things fairly soon, so don't worry about those for now. We can actually retrieve lots of other information about the cluster's nodes with this command by specifying a comma-separated list of columns for a query parameter named h. Right now we don't need that, so I'll leave you to explore that if you want to. You can find a link to the documentation attached to this lecture. As a quick side note, there is an API named _nodes, which returns the same data and much more in JSON. You can use it to inspect nodes in a lot of detail if you need to do some debugging at some point. I don't want to confuse you with an information overload, so you can see the command on your screen now, or check out the attached link to the documentation. As the last thing for this lecture, let's check out which indices we have within our cluster by using the indices command, also for the _cat API. You might be surprised to see that our cluster does actually contain indices. Specifically 2 indices that are related to Kibana. So what's that all about? As you know, Kibana is just a web interface for Elasticsearch. If you set up a dashboard or configure machine learning jobs, this configuration needs to be persisted somewhere. Kibana doesn't ship with a database of any kind, so where does it store this data? You probably guessed it, within Elasticsearch. Kibana persists data into Elasticsearch indices, which is what you see here. This means that if you set up a fresh instance of Kibana and point it to an existing Elasticsearch cluster, all of the existing Kibana data will be loaded. That's much more convenient than having to manage some other kind of data store. In case you were wondering, the leading dot is used to hide indices within the Kibana interface. That's just a convention, similar to how directories and files are hidden on Linux-based operating systems. Alright, that's all I wanted to show you in this lecture. We've run our first query against our Elasticsearch cluster, and we've taken a brief look at the inside. We'll get into more detail in the following lectures, so I'll see you there.